Hello folks, we're now in part 3 of the workflow that I use for PixInsight, and today we're going to discuss drizzling and why you do it. I have a telescope and a camera combination that creates an undersampled image, and what happens is that it's a wide field view, and the pixel size for the camera, the pixels are larger than the stars in some cases, or in other cases medium-sized stars, only 1 or 2 or 3 pixels are used to illuminate that star. So it gives blocky looking stars, and you'll see what I mean in just a minute. So let's go into PixInsight, and let me bring it up and first share my screen, and let's go find Pix, and there we go. And we ran the weighted batch processing script in part 2, and one of the things that we elected to do was to drizzle. Now again, if your camera combination calls for it, that's something that you would do. To find out if you need to do that, let's go to Astronomy Tools, and in my case I have a Stellarvue 70T, but you can search through this list of telescopes, and I'm going to guess yours is in here, but if it's not and you know the focal length, just enter it here. All that's really needed to calculate this is the focal length. If you have your telescope in the inventory of telescopes, though, select it, it'll figure it out for you. I use an 0.8 reducer, so my 420 millimeter field of view is multiplied by 0.8, so I have about a 336 millimeter field of view. Pixel size is 3.8, and the resolution per pixel is 2.33. So therein is the problem. Now under the scene conditions that I consider I have, where my stars at full well half maximum are between 2 and 4, actually they're slightly under that, but I am only slightly undersampled. And if you read down here, it does say that the ideal pixel size for OK scene is about 0.67 and to 2 degrees, and this combination leads to slight undersampling, and this reduces the influence of guiding errors and improves signal to noise, but at the expense of detail. So you'll see what I mean in a minute, but run your gear through here and it'll tell you whether you're over, undersampled, or you're in the ideal position. So with that being said, let's head back to PixInsight, and I want to first show you, because I've already went ahead and processed both drizzled data. I'm going to bring up HA drizzled, and I'm going to bring up HA that has not been drizzled on the same image, and we'll go to here, our master, and let's pick our HA, and that hasn't been drizzled. We don't need the rejection file, the rejection, we just need, okay. When you zoom in, this has not been drizzled. When you zoom in and you take a look at these stars, I think you can see the difference at the we'll just compare the same stars. Look at this star and compare it to this star, because these are the same stars, or that one. I think you'll see what I mean. This has been drizzled, this one has not. So the undersampling just isn't good for your stars, and this is slightly undersampled. When you have a grossly undersampled image, then it's even worse. So what we're going to do is we're going to run the Drizzle integration, and you do that by, I click on the process I've already saved, but you can go to processes, all processes, and go down to Drizzle integration. And since I knew I was going to be using this process over and over again for this camera combination and telescope combination, I just drag this out and drop it, give it a name, set icon identifier, and you can put my Drizzle whatever you want to call it, and start saving icons. I would do it in the order that you use them, and I'm going to delete that because I have my own. You don't have to change anything unless this is a one-shot color camera, and then you need to click on color filter array. Other than that, you just don't have to change anything apart from adding your data. Now, since this is integration, you're going to have to go to your registered images, and in this case I'm going to pull up the hydrogen alpha. Once you've finished integrating those with Drizzle, you'll need to go to O3 and do those, and when you're finished you'll go to your S2. So I'm going to integrate these first, and it selects them out. As you can see, XDRZ is shows so far that the HA had the linear new script applied, cosmetic correction, registration, and now we're going to drizzle. So we're going to select all of these. I think I already picked that. And then just click, voila. Now go get your cup of coffee, go sit down with the family and watch something on television, because it's going to take a few minutes for this process. I'll be back to you when it's done, and we'll take a look and see what our results are. Okay, as you know, I had already ran those Drizzle, the Drizzle integration for all three, so I could show you the results. And so what I want to do is bring those up, and so I'm going to go to File, Open, and we're going to go to Drizzle because that's where I chose to save them. And I'm going to open up these three files. And we're going to stretch. We're going to stretch. And we're going to stretch. So here's our HA. There's not a lot of oxygen, or at least I didn't get a lot. And there's our sulfur, our O3, and our HA. So that is our Drizzle data. It is a whole lot, there's a whole lot of improvement. Now it's at this point that I could select process. I would like to take my files and save this project and give it a name, but I already did that. So I'm going to delete these 3 files, and I'm going to pull up the project that I have saved, load project, and under 70T, here is the it's July, and the 70T, here's the project I saved, and so it's going to load everything. It's going to load the process icons that I had up. It's going to load the images that I had up, and it's going to load any processes that I already had applied. So here we are. I saved all 3, hydrogen, sulfur 2, that hasn't been drizzled, and I saved all 3 that have been drizzled, so that if we want to do some continued comparisons between the 2, we could do that. So that is Drizzle. It's a handy thing, great tool. It saves those combinations of pixel size to focal length that creates undersampling, and it saves your stars, it saves your image. Thank you, PixInsight, for giving us these kinds of tools, and appreciate it. So you guys have a great rest of the afternoon or evening, and see you for part 4 when we apply linear fit to our images and prepare them for a combination.